Today's notes are about graphing absolute value equations and inequalities with multipliers. And very similar to yesterday, we're going to look at the general form of an absolute value equation. That's f of x equals a times the absolute value of x minus h plus k. And yesterday we talked about how h is the horizontal shift and k is the vertical shift. And we touched on a, saying that if it was negative, we would reflect the graph. But today we're going to do a little bit more with a, and we're actually going to change the shape of the graph. And what we need you to do is to take the absolute value of a, meaning disregard the reflection for just a moment. When you take the absolute value of a, if it's greater than 1, it's going to cause the graph to stretch vertically. If that number happens to be between 0 and 1, then it's going to shrink vertically. So since an absolute value graph consists of two intersecting rays, meaning there's a ray on the left and there's another ray on the right, we can think of the multiplier as a rate of change. And if you remember 2 chapters ago, we said we could call the rate of change the slope. But that was when we were in the linear chapter, and lines have a constant rate of slope everywhere. If you look at the absolute value v, one of the sides is falling and one of the sides is rising. And since they do different things, we can't call it a slope anymore, but we still talk about the rate of change on the graph. And so the rate of change is a comparison of the change vertically to the horizontal change between 2 points. Just so you know, the multiplier does not affect the location of the vertex. Your horizontal and vertical shifts are still going to be the same as yesterday. They are not affected by this multiplier. It's just going to change the shape of the graph. So if you take a look at number 1, yesterday we learned that inside the absolute value, the graph will shift horizontally. And this one's backwards. It says +1, which you would think is to the right on a number line, but it actually goes to the left 1 space. So I go to 0, 0, I move left 1 space, and my vertex is now at -1, 0. The multiplier is the number that's out in front. The 2 is technically over 1, and I'm going to use it kind of like a slope at the beginning. I'm going to go up 2 spaces and to the right 1 space. But again, we can't call it a slope anymore because I'm not going to go down 2 and left 1 on the other side. I'm still going to go up 2, but I'm going to go left 1 space on the other side. So the left side of the graph actually has a negative rate of change. The right side of the graph has a positive rate of change. And it's not the same everywhere, so we don't call it a slope anymore. Number 2, there is not a number inside the absolute value, so it doesn't move left or right at all. The -4 is a vertical shift, and minus means we go down 4 spaces. So my vertex is now at 0, -4. The multiplier out in front is -3, technically over 1. So we go down 3 spaces because of the -3, and to the right 1 space. On the left side of the graph, you'll go down 3 again, but to the left instead. If you take a look at the first 2 graphs, the number 2, and if I take the absolute value of -3, I get +3. Both of those numbers are greater than 0. So these graphs should look a little bit more narrow to you, and that makes them taller vertically. On number 3, my graph has moved to the right 4 spaces and up 3 spaces. So the vertex is at 4, 3. The multiplier is 1/2. That tells me from the vertex to go up 1 space and to the right 2 spaces. On the other side, I go up 1 space and to the left 2 spaces. And 1/2 is between 0 and 1, and so this graph actually looks a little bit wider, which means it shrunk vertically. Yesterday we also graphed inequalities, so we'll practice with those. The positive 4 tells me to move left 4. Inside the absolute value is horizontal. Outside the absolute value is vertical, so down 1. My vertex is at -4, -1. The multiplier out in front is -1/3. So I'm going to go down 1 space for the negative and to the right 3 spaces. On the left side of the graph, down 1, left 3. Before I connect this, I'm going to look at the inequality symbol. It does not have an equal to symbol, so this one is dashed. And then I go look at the inequality symbol and I see a less than. So from the vertex, less than means everything below. And that tells me to shade the inside or the underneath part of the graph. Number 5, the horizontal shift is to the left 1, vertical shift is down 4. So my vertex is at -1, -4. The multiplier is 5, again over 1. So I'm going to go up 5 spaces and to the right 1 space. Or up 5 spaces and to the left 1 space. This one has the equal to symbol, so it is solid. And the inequality symbol is a less than, so if I go to the vertex, I shade below. That means everything that's outside of the absolute value. Last one, inside the absolute value tells me horizontally, so left 3. Outside is vertically, so up 6. My vertex is at -3, 6. The multiplier is -1/4. The negative tells me to go down 1 and to the right 4. On the other side, down 1, left 4. This one does not have an equal to symbol, so it's dashed. It's a greater than symbol, so from the vertex I'm going to go up, and that tells me to shade above or outside of the V. Last part, you need to write the equation or inequality, just like yesterday. We're going to locate the vertex, which is at 3, 1. That means my graph moved to the right 3 spaces, up 1 space. So inside the absolute value, I have x -3, that's right 3. And outside I have +1, that's up 1. Yesterday we were okay to just go ahead and put f of x equals out in front. Today I need you to take a look at the rate of change. This graph goes up 2 spaces and over 1 space. And I'm going to do that a couple of times just to check. And yes, it does go up 2 and over 1. So the multiplier out in front is a 2. Next one, the vertex is at 0, 4. That means that it does not move horizontally, so there's just an x inside the absolute value. Up 4 will have a +4 at the end. I need an f of x equals out in front, and I'm going to find the rate of change down one space to the right 4 spaces. Down one space, I'm sorry, not 4, 3, to the right 3 spaces. And when I go down, it's a -1. So the multiplier out in front is a -1/3. Number 9, vertex is at -2, -3. To move it to the right 2, I'm going to put x plus 2. Down 3 is -3. I need an f of x equals. I'm going to go up 1 space, right 2 spaces, check it again, up 1, right 2. That's a +1/2 for the multiplier. The bottom 3 are inequalities. So I'm still going to find the vertex at 6, 0. If it moved to the right 6 spaces, that's an x minus 6 inside the absolute value. It does not go up or down, so I don't need a number at the end. Put my f of x out in front. It's a solid line, so it'll have an equal to symbol. It's shaded above the vertex, so it's greater than. And my rate of change, it looks like, is up 1, 2, 3, 4 spaces and to the right 1 space. So my multiplier is a 4. Number 14, the vertex is at -2, 5. So to move it to the left 2, it'll be an x plus 2 in the absolute value, plus 5 at the end for up 5, f of x. It's dashed, so it will not get an equal to symbol. This one's kind of tricky because the shading should go off of the graph, which tells me it's above the vertex, just isn't drawn that way. So it's a greater than symbol. And if I look at my rate of change, I'm going down 2 spaces and to the right 1 space. So my multiplier is -2. Last one, the vertex is at -1, 1. So inside the absolute value, x plus 1. At the end, plus 1. That's left 1, up 1. F of x. It's dashed, so I do not put an equal to symbol. It's shaded above, so that's a greater than symbol. If I look at my rate of change, I'm going up 1 space and to the right 2 spaces.